I came in 1958. Fletcher Kurtz and Fred Spear were already here, and I joined Fletcher working to try to determine the orbit for the Explorer satellite. You know, the computer that was on a floor of that building, a huge room, I mean, it's, you know, a little teeny chip today, so. On my desk, I had a Marchant calculator. We could add, subtract, multiply, and divide. I mean, it was big-time exciting stuff. Something was in space, and we were trying to find out where it was. And it started in that building. The room was divided. At one end, we had the desk. Fletcher Kurtz and Fred Spear were there, you know, making all the real-time decisions. And I had one of those desks. I was doing some of the analytical work. We had teletype machines at one end of the room. Tommy Rankin was sitting at the teletype machines and talking remotely to the folks scattered all around the world that were sending us the teletype data. And Mike Nomcheff was the coordinator.
If she wanted to reach me, I was on one side and she was on the other side, and the curtains were drawn. There was a curtain there. They were trying to separate the teletypes from the people that were working. And so what she did, she tied a string on my ankle when she wanted me. She'd pull me, and I'd have to go in there and work it.
Hey, you do what you have to do at the time. So we needed an intercom system, and that was it. So you figure out what the best solution is for the circumstances you find yourself in.
There's nothing that's really impossible. You just got to figure out how to do it. And you got the brains to come up with ideas. You just have to figure out which ones look like the best idea and try it. If that didn't work, you try something else. And just keep on trying until you find one that works. That's what the human ingenuity is all about, figuring out what is right.
Explorer 1 was only the first in a long series of satellites that were very diverse. About the only thing they shared in common was the name Explorer.
As the U.S. began to launch satellites, and the Army was launching them every 2 to 3 months, Edward R. Murrah, who was pioneering television with his See It Now, decided to do a program on the birth of a satellite. In order to do that, the plan was to film the launch at the Cape and then switch over to our activity, our pre-HOSC activity, early orbit determination activity, and actually show a handover from Kurt Debus in the blockhouse to Fred Spear in the ABMA computation lab.
The flight safety people can cut it off if it misbehaves. This is the only control that we as humans have.
When the bird lifted off, it went out of control after about 5 seconds, and the range safety officer destroyed it, and the cameramen packed up their cameras and went home, and we never got to finish the show. Murrah was inventive, and I'm sure he had some money invested in what he had done, so he waited a year and made a good program out of it, focused on this was the way the satellite business was. You had failures, and then you rebuilt and went back to work and launched again. And so he showed the failure and then went on to show the launch of a successful satellite. But our quick look activity was left on the cutting room floor.
By the end of 1960, the big story was that the Army rocket team transferred to NASA's Marshall Space Flight Center when it was opened by President Eisenhower. Germans and Americans, for the first time, worked together to conquer space in the name of peace, albeit by outgunning the Russians in an unprecedented technological duel. Both sides began to square off.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
It was clearly a new era in the space age. There was a lot of work to be done in a relatively short time. That was especially true for the people in the HOSC.
The roots of it were in the early Explorer program, but it really was born at the beginning of the Saturn program, when the Kennedy Space Center was spun off from the Marshall Space Center, and Dr. Von Braun and Kurt Debus at Kennedy wanted to retain a tie. They felt that there was a close tie between the engineers, the development engineers in Huntsville and the launch engineers at the Cape, and they wanted to maintain that relationship, and so they created the Launch Information Exchange Facility to foster communications between the two groups. And the LEAF, as we called it, was communications, but you had to have a place for the people to communicate, and that was the HOSC, the Huntsville Operations Support Center.
The plan to put a man on the moon involved developing a series of rockets. The earliest of these were built to research and develop technologies needed for the actual journey to the moon. So the name Saturn was not one type of rocket, but rather an evolving class of boosters. Saturn I Block 1 consisted of an S1 first stage with 8 clustered H1 engines and a dummy second stage. Block 2 brought in a live S4B upper stage with 6 RL-10 engines.
For the Saturn I launches, the HOSC was established in a conference room on the second floor of M-Wing in Building 4663. And there were about 40 managers and engineers that crowded in there for each launch countdown and launch. We had data that came up by teletype and voice from the Cape, and it was initially hand-plotted actually on the walls after liftoff. The post-flight data was also plotted on the walls. We put it out on oscillograms, and then the oscillograms were hung up and down the wall outside in the hall where people could go look at it.
On later flights, the wall plots were replaced by video monitors that showed closed-circuit television of data displays generated in another room, still partially by hand. An early science experiment, Project Highwater, used a dummy S4 stage that contained water for ballast. The water, 22,900 gallons, was released, creating a spectacular and never-before-seen cloud, allowing studies of water dispersal at a high altitude. Other scientific payloads on the early Saturns were the 3 Pegasus satellites. These satellites, flown on SA-9, 8, and 10, made measurements of micrometeoroid density in space to verify the safety of spacecraft designs. The HOSC added a special teletype and strip chart recorder for the launches. The Saturn 1B had 2 stages, a modified S1 first stage and an S4B upper stage. The Saturn 1B was the first and last to carry a manned Apollo capsule into space.
For the Saturn 1B program, we needed more space, and so we moved into the new addition to the building. And we had a large main conference room there that seated several hundred people. And the walls were covered with corkboard so that the post-flight oscillograms could all be spread out and plotted there.
The data reduction branch of the computation laboratory extended its capabilities to include real-time processing and display. The first commercially available large-screen television projectors, Swiss-made Idaphors, were installed to provide displays in the main conference room. Closed-circuit television was provided from the Launch Control Center at KSC. 50 kilobits per second of real-time data was now received during countdowns and launches and processed by the Data Reduction Center with a state-of-the-art Burroughs B5500 computer. Now real-time data was provided to engineers in an engineering console room. Those consoles were equipped with analog meters, event lights, and strip chart recorders. A new 4-wire voice switchboard was also installed that featured highly advanced for the era conferencing capabilities. It was called the Leaf Board.